Children, today we are going to see few more terms in the unit light. We all know that when a light ray falls on a polished surface, it reflects into the same medium. But when it falls on the transparent material, it is not reflected completely, but a part of it gets reflected. The remaining gets refracted. Yes, a part of it's absorbed and most of the light passes through it. But it cannot travel with the same speed because the medium has been changed. So, the light rays traveling from a rarer medium like air into a denser medium like glass or water are derived from their straight line path. This bending of light about the normal means the dotted lines. The bending of light about the normal at the point of incidence as it passes from one transparent medium to another is called refraction of light. Look into the picture. A glass beaker has been filled with water and a pencil has been placed. Now look at the pencil through the beaker. Does it appear straight? No. It appeared to be bent at the surface of water. This is called refraction. In this activity, the light rays actually travel from the water into the rarer medium, that is air. As you saw earlier, when a light ray travels from denser medium to a rarer medium, it is deviated from its straight line path. So, the pencil appears to bend in the glass of water. Here, water is a denser medium and air is a rarer medium. So, refraction means it is the bending of wave when it enters the medium, that is, when the medium changes. The speed of light gets different. So, when it travels from denser medium to rarer medium, it bends away from the normal. At the same time, when it travels from rarer medium to denser medium, it bends towards the normal. Refractive index. Refraction of light in a medium depends on the speed of light in the medium. When the speed of light in a medium is more, the bending is less. And when the speed of light is less, the bending is more. So, the amount of refraction of light in the medium is denoted by a term known as refractive index of the medium, which is the ratio of speed of light in the air to the speed of light in the particular medium. It is also known as absolute refractive index and is denoted by a Greek letter which is pronounced as mu. So, mu is equal to speed of light in air divided by speed of light in the medium. And speed of light in air is represented as c. Speed of light in the medium is represented as v. So refractive index is a ratio of two similar quantities speed, and so it has no unit because it may get cancelled, no? Since the speed of light in any medium is less than its speed in air, the refractive index of any transparent medium is always greater than 1. See here, a list of refractive index of different substances are given. It starts as air has the refractive index as 1 and ends as diamond has the refractive index as 2.41. In general, the refractive index of one medium with respect to another medium is given by the ratio of their absolute refractive index. Yes, see here, the absolute refractive index of the second medium divided by the absolute refractive index of the first medium. So what happens here? The speed of light is the same for everyone, so it will get cancelled. So the ratio is between the absolute refractive indices. Thus, the refractive index of one medium with respect to another medium is also given by the ratio of speed of light in the first medium to the speed of light in the second medium. Snell's law. Refraction of light rays as they travel from one medium to another medium obeys two laws, and they are known as Snell's law. The first law is incident ray, the refracted ray, and the normal at the point of intersection all lie in the same plane. The green color represents the incident ray, the red color represents the refracted ray. The point where it meets is said to be point of intersection. All lies in the same plane. The second law, the ratio of the sine of the angle of incidence, it is marked as theta I. The sine of angle of refraction, which is marked as theta 2, is equal to the refractive index of the medium, that is always constant. See, the formula is given. N1 sin theta 1 is equal to N2 sin theta 2. Next term, dispersion of light. The splitting of white light into its 7 constituent colors on passing through a transparent medium is known as dispersion of light. So, when white light is passed through a transparent medium, it gets dispersed into 7 colors. See in the picture, the light passes through a prism, and when it's come outside, it has 7 component colors. Let us learn this term dispersion with an experiment. As we discussed earlier, if we keep a white screen near the prism and with the help of a torchlight, if we allow white light to pass through, what you can observe? You can observe that white light splits into 7 colors. They are violet, indigo, blue, green, yellow, orange and red on the screen. Now, place another prism in inverted position, that is upside down, between the first prism and the screen. What do you observe on the screen now? You can observe that white light is coming out of the second prism. In this activity, you can see that the first prism splits the white light into 7 colors, and the second prism recombines them into white light again. Thus, it is clear that white light consists of 7 colors. Don't you get a doubt? Why does dispersion occur? It is because light of different colors present in white light having different wavelength, and when they travel at different speed in the medium. Already discussed that refraction of a light ray in a medium depends on its speed. So, the colored light has different speed. The constituent colored light are refracted at different extents inside the prism. Moreover, refraction of light ray is inversely proportional to its wavelength. Thus, the red color of light, which has a large wavelength, is deviated as less, while the violet color light, which has a short wavelength, is deviated more. Let us see an example. The formation of rainbow. Yes, it is an example of dispersion of white light. This can be seen on the opposite side of the sun. After a rainfall, large number of droplets, water drops, still remain suspended in the air. When white light passes through them, it is splitted into 7 colors. That is rainbow. Dispersion of white light from a large number of droplets eventually forms a rainbow. Thank you.